Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 20 from the February-March 2023 paper 2 extended 0580 from Cambridge IGCSE. Now this question here is about sequences, and these sequences actually look a bit more kind of challenging than the normal sequence questions. So this is one of the reasons why I'm answering this question now. Now, one of the things I always stress to my students right from the beginning of the course, because it helps you in many different topics, is to know some of the special numbers. And I can see from this first sequence here straight away how this is related to one of the set of special numbers. Okay, I can see it straight away just by looking at those numbers. I can see the relationship between these numbers and those special numbers straight away. And this is only worth 2 marks. To go through the hassle of figuring out what type of sequence it is, if you have no idea in the beginning, and looking at the differences first and trying to figure out, do you have to multiply by the same number each time, and what do you have to add to each number, and then look at the second row and then look at the third row, work out what type of sequence it is. All of that time for 2 marks, it's a bit much, right? So some of these questions, you can answer them in a very or relatively simple way if you have some idea of these special numbers. If you have no idea what these are in your head, it's going to be difficult for you to answer such a question, right? So always try to remember at least the first few of the special types of numbers, like for example the square numbers. If you have n equals 1, 2, 3, 4, 5, then n squared would be 1, 4, 9, 16, 25, and also the cube numbers, because we have to deal with cubic sequences. So look at the cube numbers as well. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So you should have an idea of these numbers in your head. Now, when you look at this list over here, that should kind of give you some sort of an idea of what I mean. That these numbers 1, 8, 27 and 64, like 63, 27, 26, so 64, 63, 27, 26, 8, 7, 1, 0. So these numbers here are definitely linked to those numbers there. So I've got a very strong idea that this has got something to do with n cubed somehow. Something to do with n cubed. Something to do with the cubic numbers, right? And what I'm going to do is I'm going to write down. So this is our sequence. This is the first term of our sequence. I'll write this kind of upside down so we can see. So basically this number here is linked to 64. And this number here is linked to 27. And this is linked to 8. And this is linked to 1, 8, 27, 64. So this is like 1 cubed, and this is like 2 cubed, and this is like 3 cubed, and this is like 4 cubed. So if you follow that pattern, then this should be something like 0 cubed, because 0, 1, 2, 3, 4. All right, and 0 cubed is 0, and that follows that pattern. All of these, you've got to take away 1 to give you the number on top. We're going this way. Right, so 64 minus 1, 63, 27 minus 1, 26, 8 minus 1, 7, 1 minus 1, 0, and 0 minus 1, minus 1. Okay, so now what I've got to figure out is what the actual sequence is. I know in terms of n, this would be the first term, the second term, the third term, the fourth term, and the fifth term. So what is this here? What is this? All right, so when you have a 1 here, this is 0 cubed. When the second term is 1 cubed, the third term is 2 cubed, the fourth term is 3 cubed, the fifth term is 4 cubed. All right, and then minus 1. Okay, so I know you got a minus 1 at the end, but it's going to be something cubed minus 1, right? So now let's think about, for example, the sixth term. Well, that will be 5 cubed. Let's think about, for example, the 19th term. Well, that's going to be 18 cubed, right? 1 less than that number cubed. So whatever number comes here, for example, if I write 127, this is going to be 126 cubed. So if this is n, then this is going to be this number minus 1 and then cubed. You take away 1 from it and then cube it. Like I took away 1 from 127, then cubed it. I didn't write, for example, 19 cubed minus 1. I wrote 19 minus 1 and then cubed. This is 5 minus 1 and then cubed. So this is n minus 1 and then cubed. So this line here is n minus 1 and cubed, which is the same as this line. They're the same thing, right? And you got to take away 1 from it, and you end up with our sequence, which will therefore be n minus 1 cubed minus 1. So I have n minus 1 cubed and 1 less than that. And to make sure that we got the right answer, we can check this. For example, when n equals 1, we have 1 minus 1, which is 0. 0 cubed, which is 0. 0 minus 1, which is minus 1. When n equals 2, you have 2 minus 1, which is 1. 1 cubed is 1. 1 minus 1 is 0. That's correct. When n equals 3, this is the third term here. This is the first, second, third term. When n equals 3, you have 3 minus 1, which is 2. 2 cubed is 8. 8 minus 1 is 7. For example, look at the fifth term. N minus 1, 5 minus 1, 4. 4 cubed is 64. 64 minus 1 is 63, and so on. So you can check it for all of them or some of them, and you end up with knowing that this is for sure the correct answer. Okay, so this is a bit more of an extension question, but having a good idea of what your cube numbers are will really help you to answer a question like this. So you should know your square numbers, you should know your cube numbers. That will really help you with such questions. All right, so that's 20 part A done. Now 20 part B. Now this is another type of sequence here that we can see. And in this case here, we can see what we have to do to get to the next term each time. All right, is we don't have to add the same number each time. Here we can see after a little while that, if you can't think of anything that you can add, second rows don't help you, whatever, you try to do that, you should try to think about what you need to multiply by each term to get to the next term. And the way you can see if there's some link is you divide the number with the one before it. So 12 divided by 24, well, that's a half. 6 divided by 12, well, that's a half. 3 divided by 6, that's also a half. 1.5 divided by 3 is also a half. So basically all of these numbers are being multiplied by a half. Always think about it in terms of multiplication rather than division. It will make your life easier. So each of these you multiply by a half to get to the next term. So when you have to multiply by the same number each time to get to the next term, that means it's got something to do with an exponential sequence where it's going to be related to that number that you multiply to the power of something. It's going to be something to do with this. Okay? And, it's going to have some n something, right? It's going to be a half to the power of n, something like that. Now, the kind of like, not cheat way of doing it, but the parrot fashion way of doing it is to memorize the formula a times r to the power of n minus 1. Any sequence that you notice like this where you have to multiply by the same number each time, that's got this common ratio. R is equal to that number that you multiply by each time to get to the next term. A stands for the first term in the sequence, which is 24. So we can say that the nth term, which is given the symbol un, is equal to 24 times a half to the power of n minus 1. Okay, so this is actually the sequence, 24 times a half to the power of n minus 1. You can write a multiplication there if you want to, don't have to. That is this sequence. And we can test it out. When n equals 1, you have 24 times a half to the power of 1. Now, half to the power of 0. N minus 1, 1 minus 1 is 0. So 24 times 1, which is 24. When n equals 2, you get 24 times a half, which is 12, of course. When n equals 3, you have 24 times a half squared, which is 24 times a quarter. A quarter of 24 is 6. When n equals 4, you have 24 times a half cubed, which is 1 over 8. 24 times 1 over 8 is 3, and so on. So you can see that this works. So that's the easy way of doing this question, by understanding that this is a formula that you can use for this type of sequence, and it's something that you should really know for this topic, although I'd prefer not to teach it in this way when I have less complicated questions like this. I like to teach it in a slightly different way, but in this question it's going to make life maybe slightly more complicated. But I'm going to just go show you what I would do supposing you don't have this formula. Supposing you don't memorize this formula and you don't know how to use this formula. You've never seen this formula before, but you know how to deal with geometric sequences in a slightly different way. So what you can do is you can think of, okay, I know it's got something to do with a half to the power of something. So what I can do is I can say, okay, let me choose any one of these numbers and think of it as a half to the power of something. So I'm just going to randomly choose, for example, let me think of the first number. Okay, let me think of that first number, 24. Right? I know 24 is the same as 48 times a half. Okay, because a half of, 48 is 24. So I know that this is like 48 times a half to the power of something. Now, that means it's going to be 48 times a half, so it's to the power of 1. And this term is going to be basically 48 times a half to the power of 2. Okay, you just increase the power by 1 each time as you go along. And this will be 48 times a half to the power of 3. And this will be, the next one will be 48 times a half to the power of 4. And the fifth term will be 48 times a half to the power of 5. So this is the first term, the second term, the third term, the fourth term, the fifth term, right? So the first term, you have here power of 1. The second term to the power of 2. Third term to the power of 3. Fourth term to the power of 4. Fifth term to the power of 5. So I can write this as 48 times a half to the power of n. Now, this is a correct answer. This will give me the same sequence when I replace n with 1. I have 48 times a half, which is 24. When n equals 2, I have 48 times a quarter, which is 12. When n equals 3, I have 48 times an eighth. 48 divided by 8 is 6. When I put n equals 4, I have 48 times 1 over 16. Okay, and 48 times 1 over 16, 48 divided by 16 is 3, and so on. So this actually is the same answer, even though it looks slightly different from this. They're actually the same thing. Okay, if I were to, for example, take this and make this into 24 times a half, I have 24 times a half. Okay, and I multiply that by a half to the power of n. Okay. Then it's going to give me, this will be 24 times, no, this would not times a half, this would be 48 divided by a half. So this would be 48 times, a half to the power of minus 1. Okay, that's going to give me, that would be 24, times a half to the power of minus 1. Okay, so 24 times a half to the power of minus 1 was going to give me 48 times a half to the power of n. It will be, this is the same as that. And we can see that when I combine these together, I get that because I have to add the powers. So I'll have 24 times a half to the power of n minus 1. So these are the same thing. All right. So whether your answer is written in this form or it's written in this form, it's perfectly fine. The mark scheme will probably say this because of this formula. But I could have been written even in terms, for example, I could have started off by saying 6 is a half of 12. So I could have started by saying this term is 12 times a half to the power of, 12 times a half to the power of 1. I could have started with this, the first term. And then this would be a half to the power of 2. This would be 12 times a half to the power of 3. And the term before it would be 12 times a half to the power of 0. And the term before that would be 12 times a half to the power of minus 1. Okay, and then I could have worked out the sequence by putting the power of n minus 2 here. Right, but it really doesn't matter which term you choose. But as I said, to save complication in a question like this, I personally would just go by using this formula right from the beginning in this kind of question, right? So it is useful to have an idea of this formula, okay? And you should really know that formula. It will help you in questions which are more complicated like this one, okay? But you can make do without them if you have to. Don't worry if your answer is not the same as the mark scheme. As long as it generates the same sequence, you're fine. So this is the same answer as that. There's no problem if I write it in this form or that form. They'll both give the same answer. But this is the form you would get if you follow this pattern here. So it's a bit more of an involved type of question. Okay, it's it's a bit more challenging. If you look at the examiner's report when it comes out of this, you'll probably see that many students did not know how to answer this question. All right, so anyway, so there's the answer. Other questions from this particular paper will be found in the playlist that will appear over here. Other questions involving sequences and series and number patterns can be found in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching. and see you soon.